Jag Sweet Bone, the exercise study that rewrites the diabetes playbook. Here's what nobody tells you about having type 2 diabetes. Your bones might be quietly falling apart even while they look fine on paper. You could have normal bone density scores, pass every screening, and still be walking around with bones that are structurally compromised in ways that make fractures almost inevitable. But new research just suggested something that sounds almost too simple to be true, that the right kind of exercise might actually fix this before it breaks. So if diabetes and weak bones feel like a locked-in consequence, what if we've just been using the wrong key the whole time? For decades, we've known that diabetes is bad for bones, not in the way you'd expect. It's not that diabetics lose bone density. Their bones are actually often denser. That's the paradox that's haunted researchers and frustrated doctors. You have denser bones that somehow snap more easily. It's like building a skyscraper with inferior concrete that looks solid but crumbles in the wrong wind. Doctors have focused on treating osteoporosis, that classic bone-thinning disease. But type 2 diabetics often slip through those nets. They don't fit the diagnostic criteria, so they don't get the intervention. Nobody's been asking, what if we could prevent this problem entirely before it becomes osteoporosis? This new study comes from Italy, from researchers at the University of Rome La Sapienza and Sant'Andrea Hospital, led by Salvatore Balducci and his colleagues. The work was published in May 2026 in Diabetes Research and Clinical Practice, which is exactly where you'd want this conversation happening. These aren't fringe scientists. They're working in metabolic disease and exercise physiology, publishing in peer-reviewed journals with real clinical weight. The study bears the name Sweet Bone, which stands for Study to Weigh the Effect of Exercise Training on Bone Quality and Strength in Type 2 Diabetes. Somebody on the naming committee had fun with that acronym. Here's what they actually did. They took elderly people with type 2 diabetes, we're talking people mostly in their 60s and 70s, and they split them randomly into two groups. One group did structured exercise training, the other group, well, they carried on as normal. This isn't a small, sloppy study. We're talking about a properly randomised clinical trial with real methodology. Think of it like this. Imagine a gym where half the members get a personalised trainer and structured programming, and the other half just show up and do whatever they've always done. Then you measure whose skeletons are actually stronger at the end. The exercise group did progressive resistance training and aerobic work. It wasn't extreme. It was the kind of thing an actual elderly person with diabetes could sustain. They measured bone health using non-invasive methods, sophisticated imaging and biomarkers, not drilling into people's femurs to see what's actually happening inside. The findings are genuinely interesting. The exercise group showed measurable improvements in bone quality markers compared to the control group. We're not talking about dramatic transformations. The effect sizes are real, but modest, which is how real human biology actually works. Their bones didn't turn into titanium. But the structural quality improved in ways that matter for fracture risk. The studies measured things like bone turnover markers and imaging that looks at trabecular structure. That's the internal scaffolding of your bone that determines whether it'll hold up when you fall. The control group basically stayed the same. They didn't get worse in most measures, but they didn't improve either. Meanwhile, the exercise group moved the needle. Their bones were mechanically more resilient. The improvements correlated with the amount of exercise they actually did, which is a good sign that this isn't placebo or natural drift. More exercise, better bones. Less exercise, less improvement. That's the dose-response relationship that gives researchers confidence they're measuring something real. What does this actually mean when you're 58 years old and your doctor just told you you're pre-diabetic? It means several things. First, if you have type 2 diabetes, your bone health isn't necessarily written in stone, pun absolutely intended. It's modifiable. You can do something about it that doesn't involve taking another pill or getting another injection. Second, the exercise prescription doesn't require you to become a CrossFit athlete. This was moderate, structured, progressive training. Walking, resistance work, stuff that exists in normal gyms or community centers. Third, it works specifically in the window before you develop osteoporosis, which is crucial. You're not trying to reverse an established disease, you're trying to prevent something from ever taking hold. That's always cheaper and more effective than treatment. But here's what's important to say honestly. This study has limits. The participants were a specific population, elderly Italians with type 2 diabetes, but without osteoporosis. If you're younger, or from a different population, or you already have osteoporosis, we don't know if the same effect holds. The study didn't go on for decades, so we don't actually know if this translated to fewer fractures in the long term, though the mechanistic improvements are encouraging. The effect sizes are real but modest. We're not talking about transformational change, we're talking about measurable improvement in the right direction. And like all exercise studies, there's a massive self-selection bias built in. People who could stick with a randomised exercise protocol might be fundamentally different from people who couldn't, in ways that matter for bone health. Where does this fit in the bigger picture of diabetes research? It suggests that the field has been asking the wrong question. Instead of focusing on bone density alone, we need to think about bone quality. The two aren't the same thing. And it reinforces a pattern we're seeing across research. Exercise is shockingly broadly effective. It's not just good for your cardiovascular system or your blood sugar control, it's systemic. It's rewiring your entire metabolic machinery. But we still don't fully understand why. What's the mechanism? Is it the mechanical loading of exercise that stimulates bone-building cells? Is it the improvement in insulin sensitivity that changes bone metabolism? Is it the anti-inflammatory effects of regular activity? Probably it's all of those things, but we need more specificity. What's the obvious next question? Do these improvements actually prevent fractures? You'd need a study that follows people for years, tracks their falls and breaks, and sees if the exercise group really does better. That's expensive and slow, which is why it hasn't been done yet. You'd also want to know if this works in younger diabetics, and in type 1 diabetes, and in different populations around the world. Turns out, scientists have been busy, and they're not done yet.